Hello everyone, and in this video we're going to be looking at November 2021 paper 2 for Edexcel. So without any further ado, let's get into it and have a look at it. Right, question 1, it says write down the inequality shown on this number line. So the first thing to note is that we've got a circle that is not coloured in, so it's a strict inequality and it starts at -1, so its x is greater than -1 because it's not coloured in. On the number line below, show this inequality. Okay, so its x is less than 4, so we start off by drawing a circle over 4 that's not coloured in, but greater than or equal to -3. So when we have greater than or equal to, we colour in the circle. And because it's in between those two values, we represent it as this kind of like bar or dumbbell type thing. I've put on the left-hand side as well the mark scheme so that you can see where the marks are and any other ways that there are to approach the question. Let's look at question 2. It says find the highest common factor of 60 and 84. So the first thing to do is to do our prime factor decomposition of both of these numbers. So I just divided it by 2, that gives us 30, divide by 2 again, that gives us 15, and 15 is 3 and 5. So there's our prime factors. 84, again, divide by 2, gives us 42, divide by 2, gives us 21, and 21 is 3 times 7. So that means that 60 is equal to 2 times 2 times 3 times 5, and 84 is 2 times 2 times 3 times 7. Now, I think that when working out HCF and lowest common multiple, a really good way to do this is to represent it in a Venn diagram, okay? So if something is in both of these lists, then it goes in the middle, okay? So we've got a 2 there and we have got a 2 there. So 1, 2 can go in the middle. We've got another 2 there and another 2 there, so a 2 can go in the middle. We've got a 3 there and a 3 there, so a 3 can go in the middle. So we've used up a 2, 2 and a 3, a 2, 2 and a 3, and it can only go in the middle there if it appears in both, if it's a prime factor of both of them. Then whatever's left, in this case for the 60, we just have the 5 left, so we put that on the outside. And in the case of the 84, we just have 7 left, so we put that on the outside as well. And that's our Venn diagram done. Now, the highest common factor is going to be given by 2 times 2 times 3. So in this case, it is 12. And although it doesn't ask it here, if we had to work out the lowest common multiple, the lowest common multiple would be given by 5 times 2 times 2 times 3 times 7. So that's how you'd work out the lowest common multiple, the LCM. But the highest common factor is just these numbers in the middle times together, which is 12. Now we've got two different numbers here, 24 and 40, and we've got to find the lowest common multiple LCM of both of them. Now this is an alternative approach for this one. I've decided to use a slightly different method for this one, although I could have done a Venn diagram here as well. So what I've done here, my lowest common multiple is I've just basically listed like the times tables, okay? So I've listed the 24 times table and I've listed the 40 times table, and the lowest common multiple is the smallest number that appears in both of these lists, which in this case is 120. I could have done the Venn diagram approach. Let's just look at it if I'd have to write down here, or I could have done this with the Venn diagram approach, okay? I would have done 24 and listed it as a product of its prime factors, so that would have been 2 and 12, which would have then gone to 2 and 6, which would have then gone to 2 and 3. I would then do the same thing with 40, which would go to 2 and 20, which would go to 2 and 10, which would go to 2 and 5. Okay, so in the middle, we've got a 2 in both lists, a 2 in both lists, another 2 in both lists. This is our 24 here, and this is our 40. So in 24 we have a 3 here, and in 40 we have a 5 here. Okay, that's perfect. So the lowest common multiple, the LCM, if we're doing the Venn diagram approach, is that number, that one times that one times that one times that one times that one, which is going to be 3 times 2 times 2 times 2 times 5. When we work all of those out, let's just see what that gives us on the old calculator. 3 times 2 times 2 times 2 times 5 is 120. Okay, so that's the alternative approach for using a Venn diagram for that question. Perfect. Right, let's have a look at this next one. Question 3. Question 3, what does it say? There's the mark scheme so you can see where the marks are. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. Okay. Work out Sam's speed in kilometers per hour. Okay. For the first 15 minutes of the journey. Okay, so Sam sets off at 10 o'clock, and here we are at 15 minutes. This is us at 10:15. And we can see that Sam has achieved a speed of 20 kilometers. He's traveled a distance, rather, of 20 kilometers. So what we have here is speed is distance divided by time. The distance is 20 kilometers, but be careful. Notice the question says in kilometers per hour, okay? Whereas this is time in minutes. So we need to convert the minutes into hours here. So I've done 15 divided by 60, which is a quarter of an hour. So it's 20 divided by 0.25, which is 80 kilometers per hour for part A. Now, part B, at 10:15, Sam stops for 10 minutes, and he then drives on for 20 minutes at a speed of 75 kilometers per hour. Okay. On the grid, complete the travel graph for Sam's journey. So here's Sam. He has a little break for 20 minutes. Okay, so let's have a look. No, he stops for 10 minutes. I'm sorry, 10 minutes. So that is going to be from 10 past 10:15 till 10:25. So there's 10 minutes rest, and he travels no distance in that time. Then he carries on at a speed of 75 kilometers per hour. Okay. On the grid, complete Sam's travel graph. So let's have a look and see how far he's going to travel. So he's going to go 20 minutes at 75 kilometers per hour. Now, distance is equal to speed times time. So the distance that Sam will travel is the speed times by the time. And notice, again, because this is in kilometers per hour, we've got to make sure we're converting from minutes into hours. So 20 divided by 60 is going to be in hours. 75 times that is 75 times by a third, which is 25 kilometers. So we know that in these next 20 minutes, Sam goes 25 kilometers. So we can represent that. So that's 10 minutes, that's 20 minutes, and then he's already done 20 kilometers, so he needs to go up to 45 kilometers, okay? And that's how we do question 3 there. Very good. Let's have a look at question 4. Question 4, it says complete the table of values. Now, a word of caution here, be super careful with these negative ones, okay? What we've actually got to work out is you must remember that whenever you're dealing with a negative number, you put it into brackets, okay? So we have minus. Notice that this -1 is in brackets, okay? That's really, really important to have that minus in brackets. So otherwise, everything goes wrong when we try to work that out, okay? Perfect. So let's have a look at the next one. -2 times by -1 plus 2. So we've got 1 plus 2 there, because -2 times -1 is plus 2, and we've got plus 2, so we should get 5 there. So just be very careful. The -1 is in brackets, and this minus come together to make a plus. So we actually have a 5 there. It's not so crucial to put them in brackets when you have positive numbers, because we've just got 1 squared -2 times 1 plus 2, and that gives us 2. So these are the correct values that we get. It's a quadratic curve. So the fact that it's quadratic, we know it should be looking for it to look something like that. So things will have gone wrong if it doesn't look like that, okay? And then we just simply plot those coordinates that we've got there in order to get our graph. So that's part A and part B. Part C, now this is interesting. Use your graph to find estimates to the solution. X squared minus 2x plus 2 is equal to 4. Now, sometimes, depending on where this comes in the paper, they can like change this equation here compared to this one. Because this is quite early in the paper, this equation is the same as this one. So we put it equal to 4. Now, when something's equal to 4, you just need to draw a horizontal line across at 4, and the solutions are where the line and the curve intersect. So we just need to read off those x values of where the line and the curve intersect. and I've written them as minus 0.7 and 2.7. But we can see that there is a range of values, anything from minus 0.65 to minus 0.8, and from 2.65 to 2.8 is the range of values that the mark scheme would be prepared to accept as being correct for question 4. Very good. Question 5. Here is a right-angled triangle. Okay, the shape below is made from 2 of these triangles. Work out the perimeter of the shaded shape. Give your answer to 3 significant figures. Okay, so we've got to, first of all, we could do with knowing the length of our hypotenuse. And that's going to be Pythagoras. So we're going to do 8 squared add 10 squared square rooted. It's going to be 64 add 100, so root 164, and that is 12.0806. Okay, so we know that length there. Now let's consider our perimeter. Well, we've clearly got an 8, we've clearly got an 8, we've clearly got a 10, and we've got one lot of this hypotenuse. The only awkward bit is, how on earth do we know what this little bit is here? Well, let's consider how we're going to work out that little bit. We know that this whole length here is 12.806, and we also know that this side is 10, and that is that side there. So this little bit is the full length of the hypotenuse, take away 10, so 2.806. So therefore our perimeter is 8 add 8 add 10 add 2.806 add 12.806. And all of that together, when we round it to 3 significant figures, is 41.6. The tricky bit there, I think, was knowing how to find that little bit there. All right, next question, question 6. ABC is a right-angle triangle. Let's scroll on. I'm not keeping up here. There we go, question 6. ABC is a right-angle triangle. Let's have a look. Work out the length BC. Okay, so a little bit of SOH-CAH-TOA. So I've written down here our old SOH-CAH-TOA. Now, I think, first of all, we should label the sides. We're going from this angle, so that's the adjacent. This one is the opposite, and this one is the hypotenuse. I've got the adjacent, and I'm being asked to find the opposite. So I need to identify the trig ratio that has to do with opposite and adjacent, and that is tan. So tan of 65 is opposite divided by adjacent. So tan of 65 is O, what I've called O, which is really BC. And maybe I'll write that as BC actually. No, leave it as O, divided by 12. So tan is opposite over adjacent. So now we multiply both sides by 12 to make the opposite the subject of the formula. So the opposite is equal to 12 times tan 56, which turns out to be 17.8 to 1 decimal place. Notice the question says to 1 decimal place. It's very important that we give it to that correct degree of accuracy. The next question then, PQR is a right-angled triangle. Okay, there it is. Work out the size of the angle marked X. So again, we're going to label all of our sides, adjacent, opposite, and hypotenuse when we're going from that angle. We're going to look at our trig ratios. We're dealing with the adjacent and the hypotenuse. So this time, it's going to be the cosine. Cosine is adjacent over hypotenuse. So let's look at that now. So cos x is adjacent over hypotenuse, 15 over 18. So therefore x, now when we're finding an angle, we have to do the inverse, okay? Which means on your calculator, that's the one where you press the shift, okay? So we're going to press shift and cosine, and then 15 divided by 18, and that gives us 33.55, okay? But again, it says to 1 decimal place, so that's going to be 33.6 when we give that answer to 1 decimal place. So that's how you would do question 6 there. Right, I think I'm going to leave that there, those 6 questions, and start this next one in the next video. So I hope you found that useful, and I'll see you in the next video for the next question.